drill for a session on Taylor and Maclaurin series, just to cement a few ideas before we start talking about it. So I'll run through the questions and then pause the video, you have a go and then look at the solutions. So number 1, differentiate that, y equals 4x cubed. Number 2, differentiate this function e to the x. For 1 and 2, use the correct notation for the differential. Number 3, if fx equals 3x squared, then what's f3? Number 4, 10 factorial. What's the answer to that? You can use your calculator for that if you want, but think about what it means. Number 5, this series, 1 plus x squared and so on, does that series converge or diverge as the power of x tends towards infinity? And number 6, minus 1 cubed. Okay, pause this video at this point and then when you've had a go, come back and look at the solutions. So number 1, where if I wanted to differentiate this function y equals 4x cubed, I'd use the notation dy by dx, and then that equals, bring the power down, 4 3s are 12, take 1 off the power, 12x squared. Number 2, if we've got to be using fx for the function, then the notation for the differential is f prime x to represent the first differential. And this particular function, the exponential function, it's its own differential. So that's the only function where if I want to know the gradient at a point, that's the same as the value of the function at that point. Number 3, this notation means that I want to know what the value of the function is when x equals 3. So I'm actually after this value. So 3 squared is 9 times 3, 27. Number 4, 10 factorial means 10 times 9 times 8 times 7, and so on. And so if you put that into the calculator, you'll see a button on your calculator that will actually give you 10 factorial. And it turns out to be a large number, 3,628,800. Number 5 is an interesting one. If you substitute in a value for x, then you can see whether or not the series diverges or converges. If you put a value of x greater than 1 in, then actually x squared is going to be bigger than x cubed is going to be bigger than x squared, and so on. So the series diverges, gets bigger and bigger and bigger. But if we put a value of x which is less than 1, then you'll see if I square the value of x, try it for yourself with a calculator, the answer is smaller. So x squared is smaller than x cubed is smaller than x squared, and so on. So if my value of x is less than 1, then the series converges. So we have a situation where the series could converge or diverge depending on the value of x. And so we would say that if x, the value of x, is less than 1, and these lines here, these two vertical lines by the x mean the magnitude of x, i.e. the absolute value of x, ignoring the sign, then the series converges. And that could be the range over which this series converges. So long as x is less than 1, the series will converge. X greater than 1, the series will diverge. Finally, minus 1 cubed, minus 1 times minus 1 is plus 1 times minus again is minus 1. And if you think about minus 1 to the power 4, that's going to equal plus 1. Minus 1 to the power 5 is going to equal minus 1. So we actually have a situation where if I change the power, I'm going to change the sign, which we'll see will come in handy. Okay, so that's the drill.